This video is about finding the shadows of a horizontal pole. We can think of a door or a window being divided into vertical poles, which I described in my last lecture, and horizontal poles, which is the subject of this one. The basics of shadow casting is what I call the light triangle, which I described in my last lecture. But briefly, the light source is connected to the vanishing point for the shadows by a vertical reference line. And this vanishing point must be on the casting surface. To find the shadow, you send light rays over the top of a pole and shadow lines under the bottom of the pole, and where they meet is the end of the shadow. In this picture, we can make each person a pole and then find the light that goes over the top of them to the end of their shadow, and the shadow line that goes through the bottom to meet the light at the end of the shadow. And when you do that, you find that all the shadows go to this vanishing point here on the horizon, and all the light rays go to the sun vertically above this vanishing point. We can determine the shadow for this door using vertical poles, and for each one, you draw light rays through the top and shadow lines through the bottom so you can find the intersection of the two. And here I drew light triangles, so we have one intersection here, one here, and we see that the shadow lines diverge because we're looking at the sun. To find the shadow of this rectangle, let's put it in one-point perspective. So draw the vertical lines for both sides and have the tops and bottoms of those sides converge toward the same vanishing point on eye level. Eye level is the location of the viewer's eye in space, so we're looking down at this rectangle. Whenever lines converge toward a vanishing point on eye level, they must be horizontal with the ground. So these are horizontal converging parallel lines. Finding the shadow of this rectangle is then easy. We draw two light triangles on either end, as you see here. So we get these green dots. We connect them together, and all this is the shadow. And notice that this shadow also converges towards the same vanishing point as the object. To find the shadow of this horizontal floating pole, we first need to establish seats, which are vertical lines at either end connecting the pole to the surface. And we know it's the surface because shadow lines from the vanishing point go through the base of these seats. The light rays go through the top of the seats, and that gives us the two ends of the shadow. Now the shadow converges to the right along with the pole and the seat line because they're all part of the same structure. So they're all horizontal converging parallel lines. But the actual shadow direction is this way because the shadow vanishing point always has to have a vertical relationship with the sun. To find the shadow for this horizontal pole, establish seats to the casting surface, and run shadow lines through the bottom of the seats and light rays through the tops of the seats, and where they intersect are the two ends of the shadow. The shadow, the seat line, and the pole all converged in the same direction toward a vanishing point on eye level, whereas the actual shadow direction is toward the right. And I'm defining it as follows. It goes under the vertical poles or seats, it goes toward the shadow vanishing point, and it goes in the same direction as the light. So the light is going to the right, so the shadow lines must also go to the light. Now, since this light is parallel, it makes the length of this horizontal pole the same as its shadow. The parallel light also makes the green lines parallel, and the shadow lines going in this direction are also parallel. For this bench, I chose this horizontal pole and established seats. Light goes through both ends of the pole down to the pseudo-sun, while the shadow lines go through the bottoms of the pole upward toward the shadow vanishing point. And where they intersect right here is a point on the shadow, here and here. And the shadow lies behind the pole because this is front lighting. Now the pole, the shadow, and the seat line all go toward the right, converging together. But the shadow direction goes to the left. And how do we know that? Because it's under the vertical poles or seats. It goes toward the shadow vanishing point, and it goes in the same general direction as the light. That means up this way. When front lighting a vertical pole, send light rays from the pseudo-sun to the top of the pole and shadow lines from the shadow vanishing point to the base of the pole. And where they meet is the end of the shadow. So this is the shadow. For a horizontal pole, set up seats that converge toward the same vanishing point. Then draw light rays through the floating ends of the pole and shadow lines through the base of the seat. And that gives you two intersections here and here that mark the ends of the shadow in back of the pole. My next video is about shadows when the surface changes.